Good afternoon, everyone. Let's look into the key point of for connections before we move on to the welding. So the key points, first check the minimum design actions for the connection types. If you recall, which we were talking about before, section 9.1.4, which talks about the minimum design actions for the connection types. This will often govern design in light framing, but not in heavy industrial structures, okay? Now, the next step is determine the type of, because we are talking about the bolted connections, determine the type of bolt tightening and tightening methods required for the application. If the bolt is in shear, need to check the bolt capacity as well as the capacity of the plates being connected for bearing and tear out failure. This is very important. So it is not only you are checking the bolt for shear failure, but you are also checking that bolts in tension and tension with shear require additional checks because we know that yes, if you have the combined case, then you need an interaction diagram like tension with shear. Connection age, end distances, and bolt spacing must also be checked because they also govern these failures like bearing and tear out type failure. Okay, that is very important that we look into all these aspects. Okay, so the important thing to note is that yes, whether the bolt is subjected to shear or tension or combined shear and tension, all these things are there. We are checking for that. So starting from whether the member can actually carry the force. So starting from that point, next step, yes, we are looking at the designing the bolts for the connections, and then the necessary checks, whether it's shear or there's tension or tension and shear check, etc. Then this edge in end distances and bolt spacings are also very important because they related to or they govern the bearing and tear out failures. Now, of course, these are also function of the diameter of the bolt and the thickness of the plates. So there's no question. If you look at the expression, these are the things which actually comes into play. But yes, still one need to look at, for example, if you look at tear out failures, which is at the edge, or even it can happen between the two bolts, they are actually related to the spacing of the bolts. Okay. So one of the easiest thing is to look at the expression of those, bearing and tear out, which tells you that what are the parameters which affect, those kind of failures. So if you quickly look at the factors. So if you look at here, sorry. So if you look at you see the bearing plate, we have these three parameters: diameter of the bolt, thickness of the plate, and you have the maximum, the fracture stress or what is called the maximum tensile strength of the plate. And on the other hand, when you have the tear out capacity, it is actually governed by two parameters. So you can see that one is the edge distance, and there is the spacing of the bolts. AE, and then of course the other parameter is the thickness of the plate and the ultimate capacity, tensile capacity of the plate. So now let's look into the welding connections. Now welded connections. Now this will not be assessed for this course, so we'll only have a general introduction about the welded connections. So you can write this is your welded connection. Welded connections. Okay. Now, welds may be either a general purpose weld or a structural purpose weld according to the welding code. So welding has a different standard. Design approaches is the same, only the 5-factor changes, see table 3.4. And there are two types of weld connections: butt welds and fillet welds. Now, before going into that, one thing I'll tell you that if you understand the bolted connection well, you'll be able to design the welded connection also, because in case of the welded connections, if you think of an analogy, when you are determining the connection, the bolted connections, the thing you are determining was what? What is the diameter of the bolt? Isn't it? Diameter of the bolts and then spacing of the bolt, those things you are determining. So in this case, the thing we'll be looking at is the thickness of the weld. Yes, thickness of the weld. And also, you will be looking at what is called the line integral or the length of the weld. That means in this case, so the length of the weld will be actually an important parameter apart from the size of the weld. So if you look into the analogy for the bolt, it was the spacing and the diameter of the bolt. So there are two types of welded connections, butt weld and fillet welds. Let's look at them. If it is there, I will erase this one. I think it is because of the little bit of variation in this or the adjustment. So that's okay. So the minimum design actions for welding, you can see this is again from clause 9.1.4, and this is just the same what we have used for the bolted connections. So I'll not repeat them. Now the strength of butt welds. Now what is a butt weld? If you look at a double V butt weld, suppose you want to weld or weld these two or connect these two plates by welding. And if you look at double V butt joint, that means double V butt joint will look like this. This is called a double V butt joint. You can have double single V, it is a double V, because if the thickness is more, we usually go for the double V type, butt weld. Suppose this is a complete penetration butt weld, and the strength of that can be considered to be equal to the nominal capacity of the weaker part joint multiplied by an appropriate capacity reduction factor given in table 3.4. This is an important one. However, still you look into the standard, what the standard says. Now, this is an important statement what we have made now, but what looking at the standard, it says when you have the complete penetration butt weld, then the design throat thickness for a complete penetration butt weld shall be the size of the weld. That means whatever size of the weld you are using, that is your design throat thickness. That is from table, clause 9.6.2.3a. So that's the clause. And then the next clause talks about the incomplete penetration butt welds. So the strength of that kind of weld, yes, it is determined in the same manner used to determine the strength of a fillet weld, with the design throat thickness determined in accordance with 9.6.2.3b. That means it is the basically your next clause. So one is the so the difference is complete penetration, and then you have the incomplete penetration, which actually varies the strength. Okay. Now what we'll be doing is we'll be looking into the fillet weld. Now fillet weld, for example, you are connecting these two plates like this. Okay. Now the plates are sitting like this. We will put a fillet weld here. So that's your fillet weld. Okay. So the strength of fillet welds, the design capacity of a fillet weld per unit length is given by this clause 9.6.3.10. What looking at this clause? So it is 5 times VW. So what is your 5 times VW? This is the design force per unit length of the fillet weld. That's what we are looking at. 5 times VW is given by this expression. So what are the parameters here? 5, of course, the capacity reduction factor. Then you have this nominal, the FUW, which is the nominal tensile strength of the weld metal from table 9.6.3.10a, which is your FUW. Then you have TT, which is the fillet weld, that's the throat thickness of the fillet weld. And then the KR is the reduction factor given in the table 9.6.3.10b to account for the length of a welded lap connection. Okay, so when you have a welded lap connection, if you recall, just like for welded bolt, the bolted lap connection, you have the factor of KR, because what happens with even the bolted connection zones, if you have, many number of bolts in a lap joint, so what happens that it can actually reduce the strength of the joint. And as a result, we have this factor KR. So similar factor exists also for a welded joint, for a welded lap joint, basically. For remember, this is only for the welded lap joint, because in other cases, if you look at other joints, the value of Kr will be 1.0. Okay. And then we have the 0.6 times Fw. It is given, which is the factor, and then of course the factor, the capacity factor is 5. Okay. Now this factor 0.6 is the reduction factor here. And in this case, if you think of that, what is the reduction factor? I mean, why you are using the factor 0.6 is because this 0.6 times Fw basically represent the shear strength. Just like if you recall the bolt, I mean, bolted connection, you have 0.62 times Fuf. In this case, we have 0.6 times Fuw. And in this case, Fuw is very important, nominal tensile strength of the weld metal. That means it is coming from what welding rod you are using. And these are some of the, these are the two figures for the different types of welds, concave and convex type of fillet weld. And you can see the throat thickness is shown here. Okay. So the key points for the welded connection: full penetration butt welds have the same strength as the plates being connected. Very important. Yeah. Fillet weld strength depends on the throat thickness, electrode type, and weld class. Very important, because if you look at the fillet weld, because they are using a welding rod, or that's the electrode, and then the electrode. So that's very important, and the class of weld affects the strength significantly. Minimum fillet weld thickness is applied depending on the plate thickness being connected. So this is also an important one. Thank you.